Hi, in this video we are going to learn about structs in Rust. Structs, short for structure, are a way to group related data together in a custom data type. They are very helpful in organizing your code and making it more readable and maintainable. You can think of a struct as a blueprint or creating objects with specific properties and behaviors. So let's create our first example and try to understand through this example. First, we are going to say struct to define structs. Then we are going to give the name of the struct. In this case, I want to say book. And now we are going to define the fields of the struct. First, I want to have a title, which will be a string. Then I want to have author, which also is a string. And finally, I want to have publication year, which will be U33. I said U33 here since the publication year cannot be negative. I don't have to say I. And now let's create an instance of this struct. I'm going to say let book equals book, and here we will say title, and we are going to give its title. We will say string from, and here let's say the way of Zen. Really nice. Next we have our author. Again we will say string from, this is from Alan Watts. And finally we have the publication year, and this will be 1957 if I'm right. Now this is the structure of our struct. So we know this struct will hold the title, author, and publication year. And here, as you can see, we have an instance of this. So we have a book which is created based on this data structure here, and which involves the way of Zen as the title, Alan Watts as the author, publication year 1957. So we have one structure, but we can have multiple instances of this structure. Now let's see how we can read this value. Here I'm going to say println, and inside this I will say the book, and this will be the name of the book is written by, and this will be the author, and we will say in, and this will be the year. So to access them, I'm going to say book.title, book.author, and finally book.publication year. If we have programmed in an object-oriented language or JavaScript, this is just like that. In those languages, to get field of an object, we use dot notation. And here we are using dot notation to get a field of the struct with the same ideology. And let's see what happens when we print it. First, we are going to say cargo build. Now we will say cargo run. And now it says the book, The Way of Zen, is written by Alan Watts in 1957. And as you can see, that's how we read the data from a structure. Now let's see how we can alter the data of a struct. For that, I'm going to create a mutable instance of this struct, because this instance is not mutable, so we cannot change the data here. If we say let mute book equals, then we are going to have the same thing here, and then we are going to say book dot publication year. Second publication was in 1989, so we are updating the data here, and then we are going to print the same thing so we can see the difference in the terminal. So let's run this again. As you can see here, we say the book, The Way of Zen, is written by Alan Watts in 1957, and here it says the book, The Way of Zen, is written by Alan Watts in 1989. So we can alter the field of a struct using dot notation like we read it, but for that we need to define the instance as mutable first. Now let's see how we can use structs in functions. First, I'm going to define a function here. I will say get book data, and here I will have a book type of book as a parameter. So we can provide this structs as parameters in our functions. And here as the return type, I'm going to say we are going to return an array of strings with length 3. And inside here, I'm going to say title equals book.title, author equals book.author, and finally publication year equals book.publication year. Next, we are going to define our data array. It's going to be an array of strings, and the length will be 3. And we are going to say title, author, and publication year dot toString here, because the data we are getting here is U32, but our array cannot have multiple data types in it, and we defined our array as string here. So I'm converting this U33 to string using this toString function. Next, I'm returning this data. And if we go here to use our function, we can say let book data equals get book data, and then as a parameter we are going to pass the book that we created. And then we are going to create a for loop, and we will say data in book data, and inside this for loop we are going to say println data. So we were using println like this, so we can also use like this, but this is another way that we can use, so I want to show it here. In general, we are going to use it the way that we use always, so that I think it's more easy and clear to see, but this is also valid usage. And let's see if we are able to get our data from the book. As you can see, we got the way of Zen Elon Musk and 1989 as the data from our book data. We can also return structs from our functions. So if we say function create book, and this function is going to create book based on the parameters that we provide. So first we are going to have a title which will be string, then we have the author which also is going to be a string, and finally we have the publication year which is going to be U32. And this is going to return our book struct, and here we will say let book equals book, and inside this we will say title is title, then author is author, and finally publication year is publication year, and then we are going to return this book. So what we did is we got parameters, and we are passing these parameters to this instance, and we are returning this instance as a book struct. For that we are saying title is title, author is author, and the publication is publication year. So let's check what this three dot says, and it says shorthand structure initialization. So what does it mean? It means that if we have the same name here in the parameter, or if we have the same name on the left side and the right side of the semicolon here, instead of saying title, we can simply say title. And this means this. I know it feels like we are putting a lot of work to do simple things in Rust, but we also have some shortcut like this. So this is the same thing that we did before. It's just a shortcut that we can use. Now I'm going to create my struct using the function here. I will say let my book, we will say create book, and here we will say the path of Zen instead of the way of Zen, and we will say toString, because we said we are going to provide string as a parameter, and then it will be my new full unique book, and then we will say toString, and finally 2023. So I just wrote it, it's purely new, it's nothing to do with the way of Zen. So before printing out this new struct that I created, we need to discuss something. So far we were printing out our variables, strings, integers, booleans, and other variables using println. And here to print this my book we are going to do the same thing. But to print it, we cannot print this as the way we were doing for other variables. For this we need to implement the debug trait. So debug trait as the functionality, so that in the debug mode we can print the values of this struct. To add the debug trait, what we are going to do is here we will say derive debug. So this will add the functionality of debugging, printing out when it's in the debug mode to our struct. Don't worry if you don't know what this means. We are going to talk about this later, and we are going to use this in a couple of places, so we are going to get used to it. But you don't need to know everything about it right away. Just know that once we add this, then we will have the functionality to print out in our book in the debug mode. So here I'm going to say println my book is, and instead of this in the debug mode we are putting semicolon and a question mark, and after this we will say my book. So let's see what's the difference here. Instead of having empty brackets, we have semicolon and a question mark, and to use this debugging functionality we added this trait here, which is derive debug. So I know it looks not familiar, but if you look at it, it's just two simple steps. We add this code so that we can print it out in the debug mode, Then to print out in the debug mode, not in the usual one, we just put semicolon and question mark here. So let's print it and see what happens. As you can see, it says my book is, and this is the struct we have as if it's in the code. So this is the debugging way. This is how we print out in the debugging mode. And we are going to use this derive debug to print our structures. So let's talk a little about tuple structs. So tuple structs are like structs, but they combine the functionality of structs and tuples. So let's create one and see the difference. Here I'm going to say struct tuple book. And here I'm going to say string u32. So instead of this, we have this. We can use tuple structs and we don't need to define the field names of the structs like this. Here we set title, order, publication, but here we don't have the names for these fields, so we just have the types that the values will come. So let's create an instance of a tuple struct. Here I'm going to say tuple book equals tuple book, and I'm going to say some book here. We are going to say to string, and then author is me, Simon, string, and finally the publication year is 2023. Now we created a tuple struct here, and this is the equivalent of this struct, but we don't have the field names. We just put the values, as you can see here. And if I want to get the title of this, so here I would say let title equals tuplebook.0. So this is the first variable we have here, which is some book. So this is just like how we access the fields of the tuple. Next, we have the author, and here we will say tuplebook.1, and for the publication year, we will say tuplebook.2. So with this one, we are getting the first field, which is some book here. For this, with this one, we are getting the second field, and this one is the last field we have. So we are accessing elements as we are accessing from a tuple, and this should be an underscore. So we can use this tuple structs in the functions as we are using the normal tuples. It's the same way of usage. We also have another type of struct which is called unit struct. We can define unit struct like this, and maybe it's better if we define here so we can see all them together. I will say struct unit book, and that's it. So for this unit struct, we don't have any field associated with this struct, so it's just an empty struct. And we create the instance the same way. I'm going to say that unit book equals unit book. So it seems like it doesn't do much, but we can actually attach methods to this struct, and instead of using its field and storing data in the struct, we can create this struct so that when the type of our variable is this struct, we can use its methods. So it's a very useful way to correlated methods in one way, and we can use this unit struct as a gateway to those functions. Now let's see how we can implement methods for structs. For that, I'm going to create a new struct because we've been working with books so much that it's getting crowded here. We are going to say struct rectangle, and first we are going to have width, which is going to be f64. Then we will have height, which is also going to be f64. And then we are going to implement methods. In JavaScript, if you are creating objects, then you would put the methods inside the object definition. If you are using Java, in Java, we would put methods associated with a certain class inside the class. But in Rust, what we are doing is, first we are defining struct, and then in a separate place, we are defining the methods associated with this struct. So here I'm going to say implement rectangle. This means that I'm implementing methods for rectangle struct. Here I'm going to say function area, and this is just a function, just a method associated with this struct. Here we were defining methods outside of the struct, and we were using this like normal methods. Here we are defining methods, and we are associating these methods with the struct here under the implement block. The first parameter I'm going to use is self. And this self parameter refers to the instance that is calling this method. If you are familiar with this keyword from other programming languages, self is like this keyword. Don't worry, we are going to use this a lot and it's going to make sense and it's going to be easier to remember what it does later once we are used to implementing functions in this way. Then I won't have any other parameters and I will say it's going to return f64. And inside this I'm going to say self.width times self.height. So this is the value that we are returning. We didn't say return because we didn't put semicolon at the end, so we are indicating that this is our return statement here. So let's call this function, and once we call this function, it will be easier what this self keyword does here. First, I'm going to create my instance. I'm going to say let my rectangle equals rectangle, and I will say quick fix. And now, as you can see, it just provided me the fields. For the width, I will say 10, and for the height, I will say 5. Now I have my instance. Then I will call my method here. I will say let area equals my rectangle dot. With this dot notation, we are accessing the method that is associated with the structure. And as you can see, it's recommending me this area method here, and then I'm going to call it. Even though we had this self parameter down there, we don't have this here because the self parameter indicates that I'm going to use this instance here. This instance refers to our rectangle width equals 10 and height equals 5. But if it was a different one, then we would use this area with a different self and which has a different width and different height field. So what happens is once we set this my rectangle.area, we call this area function here. And this area function takes the self as the parameter. The self is this here. So once we say self.width, we are referring to the instance that is calling this method, and the width of this instance is 10. And once we say self.height, we are referring to the instance height, which is 5. Basically, what we are saying here is 10 times 5, because that's the width and height of this self, which is the instance that is calling this method here. So here, my area, we are expecting it to this area to be 50, since we are saying 10 times 5 in the function below. So let's print out the value and see if it's 50. Here, I'm going to say println. And here we will say the area of the rectangle is, and then we will say area, and let's see if we were right. The area of the rectangle is 50. As you can see, we were correct. And this is how we are going to associate methods with our structures. We covered a lot here, but don't worry, the more you practice, it's going to get easier. And we are also going to use structs a lot in our later lessons, so it will be easier to remember and understand how they actually work. Thank you very much for this lesson, and I'm going to see you on the next one where we talk about enums.